Welcome to the Unit 8 Day 3 notes. Go ahead and do these warm-up questions. You probably have already done some of them, but go ahead, do those, pause the video, unpause it when you're done, and see how you did. So for this first one, we would start by subtracting 6 from both sides to get 3x is equal to 12. Then we would divide both sides by 3 to get x equals 4. That's just solving a linear equation that you've been doing all school year. Now, the same numbers are in this next example, but because we have this x squared, it's going to be a little bit different. So we still subtract 6 from both sides. So we have 3x squared is equal to 12. Then we divide both sides by 3. And then going back to Unit 4, to get rid of the squared, we would take the square root of both sides. And we'd have positive and negative 2. Not square root of 2, positive and negative 2. Because 2 times 2 is 4. Negative 2 times negative 2 is 4. Okay, this is something we've done before, and this is kind of what most of today's notes are going to be about. So the two ways that we have for solving quadratic equations. We can solve by factoring. We can solve by square rooting, we'll say. Okay, now when do we use each method? If the polynomial is factorable. That's pretty much the only option. If it's factorable, we would use by factoring. If it's not factorable, you obviously can't do it by factoring. In the square rooting, we are going to have, it's possible you'd factor something out first, like factor out a GCF, but we're going to have no x to the first power term. So we're going to have something x squared, a terrible 2, plus something equals 0. But no x here. Okay, because in that case, we'll just move that number over. We'll have x squared equals something, and we'll take the square root of both sides. So you may or may not always know which one to do. So the first thing you should always do is get everything to one side and just kind of see what happens. So in this one, I'm going to add 2x to both sides and add 3 to both sides. That gives me 3x squared plus 9x plus 6 is equal to 0. So at this point, I know that square rooting is not the method I'm going to use because I have this 9x. So I'm going to factor out a GCF. Okay, that 3, I could have divided by 3 because there's no variable there. But I'm going to end up being able to factor. This is going to be x plus 2 times x plus 1. My outsides are 1x, my insides 2x, together that makes 3x. So if I'm solving for x, now x plus 2 equals 0, or x plus 1 equals 0. So x equals negative 2, or x equals negative 1. Easy enough. Now for this next one, again, you don't always know what's going to happen, so simplify everything, get everything to one side first. So I'm going to start by distributing that 2. So the left side I didn't change at all, but the right side is now 8x minus 12. You might be able to identify it at this point, but if I subtract 8x from both sides, those are going to disappear. You'll be left with negative 4x squared is equal to negative 12. If you don't notice that right away, that's okay. Add 12 to both sides. You'll get negative 4x squared plus 12 equals 0. You'll see you have an x squared term, but no x term. And you can subtract that 12 right back over. Now I'm going to divide both sides by the negative 4, because negative 4 divided by negative 4 is positive 1. That leaves me with x squared. And then negative 12 divided by negative 4 is a positive 3. To get rid of the squared, we take the square root of both sides. The square root of x is x. When we take the square root, we have two possible answers, a positive and a negative, and the square root of 3 is the square root of 3. All right. There are times where you're going to need to simplify the radical, which is what we did all of unit number 6, and there'll be times where I say to leave it rounded to a specific value. In that case, you will use your calculator. Make sure you are following the directions for any problem that to make sure you're doing the right thing, because you don't want to lose a half a point for not following those directions but doing all the other hard parts correctly. All right. Now for this one, hopefully it screams in your face that you can solve this thing. with the square root, but you can also solve this one by factoring. So I'm going to do this one both ways. So initially, to me, this jumps out, add 25 to both sides. You'll have 4x squared equals 25. Divide both sides by 4. X squared is 25 over 4. You take the square root of both sides. 25 is a perfect square number, and so is 4. So you'll have 5 over 2 as your possible answers, both positive and negative 5 over 2. Now I said you could do this another way because this is a perfect square, a difference of perfect squares. You can have 2x plus 5, 2x minus 5 equals 0. Okay, if you do that, 2x plus 5 equals 0, or 2x minus 5 equals 0. If you subtract 5 on this one, you get 2x equals negative 5. So you get x equals negative 5 over 2. Or if we add 5 here and divide by 2, you get x equals positive 5 over 2. So both of these have the word or in them. This one's just written down. This is plus or minus 5 over 2. This is plus 5 over 2 or minus 5 over 2. They're the same thing. It does not matter which one you use. They are both perfectly valid. Now, for this next one, I would start by subtracting 3x from both sides to get everything over on one spot. We get to here. Now, this problem is the exact same situation as this last one. You can solve it by either factoring or taking the square root of both sides. I think the square root method is going to be faster if we do it appropriately, and we've been doing more factoring recently, so let's do the square root method on this one. So I'm going to add 36 to both sides. Gives 9x squared equals 36. Divide both sides by 9. X squared is equal to, well, 36 divided by 9 is just 4. So when we take the square root of both sides, we get that x is equal to positive or negative 2. So you could write x equals 2 or x equals negative 2. It's another way of writing the exact same thing. Okay, and just like always, I haven't done so in these notes yet, but just like always, we should be able to take each of these values and plug them back in to make sure we get something that is true. So if I tested the positive 2, x squared is 4 times 9 is 36. 3 times 2 is 6, so 36 plus 6 is 42. Minus 36 is 6. 3 times 2 is 6. We got the right values. Here you do the same thing with the negative 2. All right, now for this one, it says leave answer in simplest radical form. So if it says this is an indicator, a hint, that we are going to square root both sides. We're going to do square rooting. Because if we're factoring, we don't actually see square roots ever show up. All right, so I'm going to add 36 to both sides. 5x squared is equal to 45. We're going to divide both sides by 5. I'll bring my work over here. I'll use x squared is equal to 9. Now when we take the square root of both sides, square root of 9 is a nice number, so simplest radical form is actually just the whole number 3, but since it's a positive or a negative 3, we have two answers. Because remember, 3 times 3 is 9, but so is negative 3 times negative 3. So even though it says simplest radical form, you might not always end up with a radical in your answer. For this one down here, we'll add 34 to both sides. 17x squared is equal to 34. And then we divide both sides by 17. When we do that, we get that x squared is equal to 2. Now when we square root both sides, we've got x is equal to plus or minus the square root of 2. Simplest radical form is if we get something like square root of 8. Remember we did that 8 breaks down into 4 times 2, and 4 is 2 times 2. We had a group of 2. That's the sort of thing where we find simplest radical form. That's what we did all of Unit 6. Okay. Now this is just random, not part of this question specifically, but what you do if it's not like this one was square root of 9 is 3, or the square root of 2 is the square root of 2, either one. Sometimes you have a little bit more work to do after that. Okay, now this one says round answers to the nearest hundredth. For rounding answers to the nearest hundredth, you're probably going to have to take a square root of both sides. Now this one, I see an x term here, so that tells me that I don't have that. So what I'm going to do is I'm going to subtract 27 from both sides. Gives me 6x squared plus 4x minus 18 equals 0. Now I'm going to factor out a GCF. In this case, my GCF is 2. Okay, the 2, it's not really going to hurt anything in this problem now. So now when I factor this, because I had that x term in the middle, so I know I'm going to have to try to factor it. 3x and x gives me 3x squared. I need two numbers to give me 9. All right, well, I'll try a plus 3 and a minus 3. That may work, it may not work, we'll find out. All right, so outside would give me a minus 9, inside would give me a plus 3. Together, that does not give me a plus 2. So that does not work. All right, so let's try a different one. All right, well, I'll try a 9 and I'll try a 1. All right, if I do this, that's a 3, that's a 9. That also doesn't work. That tells me that I'm not actually going to be able to do this problem. And I wrote a bad problem, which will happen from time to time. So I apologize about that. So I should double check first off that I did my subtraction right. Well, 9 minus 27 is negative 18. That was my biggest worry. All right, did I factor this out correctly? 2 times 3 is 6, 2 times 2 is 4, 2 times 9 is 18. So I did all of that right, and I just can't solve this at this point because I don't have enough information. So this is a bad question, and you can just skip this one. All right, now for this next one, I'm going to subtract 2x from both sides. That gives me 7x squared minus 35 is equal to 0. So I'm going to add 35 to both sides. So 7x squared is equal to 35. When we divide both sides by 7, we get that x squared is equal to 5. So we take the square root of both sides. Now, simplest radical form would tell me it's plus or minus the square root of 5, but the directions say to round to the nearest hundredth. Hundredth is 2 decimal places. So in my calculator, I'm going to take the square root of 5. So to do that, I'm going to have to hit the second button, the one that says second, the big blue button, and then the x squared key, because it's got a little blue square root symbol above it, and then 5, and then equals. So this is going to say x equals 2.23606, whatever. That 6 tells me to round up, so 2.24. Or I need to have the negative version of this as well. My calculator is not going to give me the negative version. I need to be able to take the positive version and rewrite it as a negative. Now this next part is it's brand new. It's something we haven't done yet. We are going to be sketching a graph. All right, so what we're going to do is we're going to find our solutions. So since we're already in factored form, we have x plus 4 equals 0 or x minus 5 equals 0. So x equals negative 4 or x equals positive 5. Those are the two values, which means our ordered pairs, our x-intercepts, would be negative 4, 0, and 5, 0. So we're going to go on our graph and make a negative 4, 0 dot, which is to the left. So negative 4, 0, I'll say is right here. And a 5, 0 dot is to the right of the y-axis. All right, so I've got those two dots. Now I need to connect them. Now it would be really easy to just connect them going straight across, but we don't have a linear graph. We have a quadratic. In this case, it would be a trinomial. So it's going to have to curve. It's either going to have to curve going this way or curve going this way. Okay, there's going to be either a valley or a hill or a mountain. If we don't know which way it's going to go, we can just kind of guess a point in the middle. So a point in the middle-ish would be 0. If I plugged in a 0, I would have 4 times negative 5, which would be a negative 20, which is going to be down here somewhere. So what I'm going to do is I'm going to sketch like this. I'm going to put arrows on like that. That's all I'm expecting for a sketch. I need to see a dot at your x-intercepts. I want you to label your x-intercepts. And then it's either going to kind of look like a U or kind of look like an N. That's it. That's all I'm asking for sketching. So for this one, it doesn't give us in factored form right away. But if I add 8 to both sides, I can get 4x squared equals 8. Divide both sides by 4. I've got x squared is equal to 2. And then I can take the square root of both sides. X is equal to plus or minus the square root of 2. That means my x-intercepts are the square root of 2, 0, and negative square root of 2, 0. So I'll put a dot here. I'll say that is square root of 2, 0. Negative square root of 2, 0 will be right there-ish. It doesn't have to be exact. Now pick a spot somewhere in the middle. I didn't mean to do that. I apologize. If I pick a spot somewhere in the middle of these two dots, I like to pick 0 because it makes my life easier, because then I basically just eliminate this and I have negative 8. All right, so if I'm at 0, right in the middle here, I get a negative 8. That's further down here. So that means I'm going to be coming through something like that. Now it's not exact because I didn't even say that this would be a negative 8, because I don't even know if that's exactly where it's at its lowest point or not. I just needed to know if it's going to, like, we will say this opens up or if it would open down, which would be that way. All right, so this one is in our factored form already. So either 2x equals 0 or x minus 8 equals 0. If 2x equals 0, that means x equals 0. I'm fighting off a sneeze. Sorry about that. And if x minus 8 equals 0, that means x equals, oops, I wrote equals 0 because I said equals 0. It means x equals 8. So one of those two things is true. So my x-intercepts, which I keep finding first, are 0, 0, and 8, 0. 0, 0 is right there. 0, 0. 8, 0, I'll say, is right here. I always pick a spot somewhere in the middle. I can't pick 0 this time because that's one of my spots. So I got to pick something else. I'm going to pick 4 because 4 is halfway between 0 and 8. If I plugged in a 4, I would have 2 times 4 times 4 minus 8. So that'd be 8 times negative 4. I don't even care what that number is. I just need to know if it's positive or negative. And it's going to be negative again. So it'll be somewhere down here. So I'll have this curve like this. All right. I don't actually care what that number is. I'm just picking a random spot between 0 and 8. I just need to know if it's positive or negative. If it's negative, it's down here. If it's positive, you'd put it up here and it would curve like that. All right, sketch a graph of this one. Well, I'm just going to start off by dividing both sides by 16. Give me x squared is equal to 4. So x is equal to plus or minus 2. So I have my x-intercepts as 2, 0 and negative 2, 0. So I'll say negative 2, 0 is right there, and 2, 0 is right there. I try to make them roughly the same distance apart because 2 and negative 2 should be the exact same distance away from 0. Now I'll pick a spot in between. I'll pick 0. If I have this, I have to be kind of careful. So I plug in 0, it'll say 0 equals 64. And you'll be tempted to say, oh, 64 is up here, and you put a dot up here. But it's down here because I'm actually thinking about the graph of this. So if I replace this with a 0, I would have minus 64. So it's down at the bottom. So this is another one that opens upwards. So far, they've all opened upwards. All right, so when we're sketching the graph, we need 3 things. 2 of them are the same. So we need an x-intercept. We need another x-intercept. Both of these things should be labeled on your graph. And then we need a direction. So opens up like this, or opens down like this. Now, our examples, we didn't have any opening down, but let's go back and look at one real quick and see how it could have been opening downwards. So, for example, this one. if I had changed it to a negative 2x, that would have been a negative 2 times 4, a negative 8 times 4. That would have been a positive 32. Then it would have gone something like that. All right. You don't need to keep both in your notes. Either one's fine. I'm going to erase that red piece that we just did. But that's what opening downwards would look like. That's how we'd be able to find that. All right. So then at the bottom here, there's a spot for you to ask a question that you should be ready to ask somebody next time we see each other in class. I hope this helps. Hope it worked out okay. Have questions when you come to class, we will go through those. And I hope everybody has a great day.